Test, test. Hello, everyone. Welcome. I hope you enjoyed the talk so far. Here's our next speaker, Françoise Provencher. She's leading the data team at Local Logic, a Montreal-based location intelligence startup, where she builds data products. She did a PhD in experimental physics and a postdoctoral fellowship in machine learning. And today she's giving a talk about how to measure a city. And she will explain how some cities in Canada are designing indicators to measure how livable they are. Please join me in giving her a big applause.
So, hi, I'm Françoise. I have 2 kids and 0 car. I prefer to bring them with me around in my cargo bike. Now, this is not shocking to you at all, because we are in Amsterdam, where this lifestyle is very common. But as you can see from this picture, this is not Amsterdam. I'm wearing a helmet. I'm driving a Danish cargo bike, not a Dutch backfeet. So where is this? It's not even in Europe. It is in North America, where this lifestyle is still not common at all. I live in Montreal, or as I call it, Montréal. It's in the French-speaking part of Canada. I was born and raised there, hence my beautiful accent. And I love Montreal. I'm fortunate to live near the coolest street in the world, according to Time Out magazine. And I spent my summer enjoying all the free outdoor festivals, going to the parks, hanging out, having picnics, eating my way through all the farmers markets and the vibrant restaurant scene. I feel like Montreal is a great place to live, and I'm not the only one that thinks that. There's this little bubble of YouTube urbanism channels, and it seems that Montreal is often considered to be the best city in North America, which would make it the second best city in the world after Amsterdam, right? Yes, but of course, I'm teasing you. Montreal has a lot of flaws, but I'm teasing you with a purpose. I want us to think about what makes a city the best city? What makes a city a livable city? What does it mean for you, for your community? And if we can agree on a definition, how do we even measure that? How to measure a city? That's the title of my talk. That's exactly what we're going to talk about today. First, I will tell you, I will give you the answer, or at least one possible answer. I will tell you the story of how I measured the city of Montreal. Then I will look at some decisions that we made along the way to illustrate 5 criteria for good metrics. And those 5 criteria can be used to measure pretty much about anything. And at the end, I will get philosophical about numbers. And if you're not a city nerd, don't worry. The city part is just a good excuse to talk about more general principles of metrics in general. So there's still something in this talk for you as well. So why would we even want to measure a city? Well, city planners need to make a land use and development plan that is like a big, enormous document that thinks about how a city will develop for the next 20, 25 years. And they need to think about where people will live, how they will get around, things like nature conservancy, where will we have agriculture done, and so on. And one of the tools that is very widely used today is to use population density targets. Why population density? Well, it gives you a lot of cool stuff. If people live closer together, you have less kilometers of road, sewers, cables, and other utilities. It's cost efficient to live close together. If we live close together, also distances are a little bit shorter, so maybe your commute time from your home to your work will be shorter. Also, if people are close together, you can have maybe a critical mass of people to have like a good transit system. So we know that density is a good thing, and that's why it's currently used for targets. But density is not the only thing that matters. What matters? Access to fresh food, schools, culture, a good transit system, cycling infrastructure. It is possible to build a high-density environment without all those good things. But density is a fundamental ingredient to enable all that good stuff. So instead of measuring just density, the community of the greater metropolitan Montreal area is asking this very interesting question. Can we also start using targets like this, that by 2035, 70% of the population will live in complete living environments? Now, disclaimer, this is not yet a target that the city of Montreal has adopted. Like there's a lot of process for this kind of thing to happen, but this is the research question they approached me with. And when I say me, I actually mean the company that I work for. It's called Local Logic. It's a small Montreal-based startup founded by 3 urban planning graduates. So together with my colleague Colin Stewart, we've set out to figure out what is a complete living environment and how do we measure it. So let's start with a high-level methodology. We were inspired by the 15-minute city concept, and we worked with the city of Montreal to identify the 6 aspects that they really cared about and that they can act upon. And we designed 1 indicator per aspect. So we created 1 indicator of pedestrian access to shops and services, public transportation, cycling network, parks and green spaces, school infrastructure, and cultural infrastructure. So the first step was to assemble our big data set. So we found the location of all the parks and green spaces, the cycle paths, shops and services, all the bus stops, as well as subway and train stops, libraries and other cultural infrastructures, public schools, and many more. And then what do we do once we have all that data? Well, we pick a point on the map, and then we look at, okay, for that point, how far can we go if we walk 15 minutes? So that gives us a polygon like this. And then for each of the indicators, we count everything that is relevant for that indicator, and we transform that into a score. And then rinse and repeat with other locations. The 6 indicators are calculated on a very fine grid that covers the entire metropolitan territory of Montreal, where over 4 million people live. And that's it. We just counted stuff that was within a 15 minutes walk radius. Simple, but the devil is in the details. So this was our high-level methodology. Now let's go into some of the decisions that we made to get there. And those decisions were guided by what I like to call the 5 criteria for good metrics. So before leading the data team at Local Logic, I worked for 7 years at Shopify, where I worked on several different projects, but I think a connecting line throughout my career was measuring things. How do we measure things? And something that really helped me was when my boss and mentor, John Meyer, exposed me to this framework of 5 criteria for good metrics. It helped me to think through what I'm doing. Like it's a good checklist to have in mind that really helped me. I think that he got these from tribal knowledge from his previous role at Facebook. If you Google how to design good metrics, you will probably get different advices, but this has served me well, so let's get into it. So the first one is simplicity. Easy to understand. Simplicity helps make things more interpretable. It's easier to be transparent. It's also a bit easier to debug your metrics when they behave a bit funny. And this was paramount for this project because simplicity affords us a very important thing. Simplicity fosters trust. If your stakeholders can understand the metric, they will trust it more. And trust is very important for a project like this because these numbers are meant to influence policy. They need to be understood by city planners, politicians, citizens. So the easier to understand, the better. An important design decision that we make was we explicitly decided not to use access. What is access? Glad you asked. So access is a way of measuring things in urban planning that is very common, and it is defined as the following, is that you measure, you count the number of things, and you divide by their distance, or the square of their distance, depending on who you talk to. This is probably not super shocking or complicated to an audience of math-savvy data people, but we explained this several times over to previous clients, and it was really hard to grasp for them. Like it's much harder to develop a good intuition about that. So we thought, well, you know what? We can define metrics based on counts. Everybody understands counts. It will be much simpler, much easier to understand for our stakeholders, so let's use that instead. Now, just so that I don't confuse anyone, when I talk about access for the rest of this talk, I mean it in the normal way, like access to clean water, not access as in that special type of metric, so that you're not confused about that. Next one is faithfulness. Captures the spirit of what you're trying to represent. A very good example, or should I say counter-example of this, was when we created the indicator for parks. So there was another metric that already existed, and it would have been so simple to say, hey, this metric exists, let's just use that. But when we looked at the methodology, we found that it was not faithful enough for our purpose. So I'm going to explain it to you. The goal is to measure park access. So you start with a census area. A census area is like, where people live in that area. There's the dot in the middle represents the center or the centroid. And so this previous metric, what it was doing, it was looking at the distance between the centroid and the closest park. And that's your access to park. But get this, a census area is very arbitrary polygon that was drawn by humans, so if you draw your boundaries differently, you get a very different result. Like, this is not very faithful to what we're trying to represent. It's more like measuring like how lucky were we that the park fell near the center of a census area. Also, it doesn't take into account how many parks there are or how big they are. And those are things that we felt were important to capture in a metric, so we designed our metric to capture those things because we thought it was more faithful. So as you can see, this previous metric was more simple, but too simple to the point of not being faithful enough for our purpose. And I think you will always, bump into that case that there's always a trade-off between the criteria for good metrics, and how you navigate those trade-offs is really dependent on what you're trying to achieve. For us, in this case, we felt that being faithful to what we're trying to represent was more important than being as simple, like as bare bones simple as possible. Despite all I said earlier about simplicity being important, we had to make that trade-off. Next one is sensitivity. Captures changes that matter. It is possible to design a metric in a way that the metric will change a lot if the thing it's measuring changes a lot, but also when there's a small change that matters a lot. Let me give you an example. So if we're talking about the indicator for shops and services, let's say that I'm surrounded by 100 shops. One of them closes. I'm still surrounded by 99 shops. My experience as a shopper, a pedestrian that's trying to get their daily errands done, it doesn't change much because I still have a lot of access. So the metric shouldn't change much. However, if the shop that closed was the only grocery store, then our metric drops by a full point because we believe that access to fresh food is super important. And so the metric should reflect that opinion. What? Did I just talk about a number that embeds an opinion? We'll get back to that. Next one is precision. It affords nuance. If the metric is only high or low, it's not very precise. We want those shades of gray in between. And we had this problem with our cultural infrastructure indicator. So when you think about municipal libraries, there are not that many of them, and they are well spaced out on the territory. So either you live within a 15 minutes walk of one or 0 municipal library. So the indicator is either high or low. We needed a little bit of, a gradient between those two extreme values. So we had to think. And the way that we solved for this is we introduced a 5 minutes walking radius so that the municipal library would count twice, once in the smaller and once in the larger walking radius. So already there we can have high, medium, low. It's a little bit better. But culture is not just about municipal libraries. You have other type of infrastructures, such as museums or cinemas. And so we gave a different number of points for the different kinds of cultural infrastructure. So for instance, our municipal library is worth more than a commercial cinema, for instance. And that is another example of how numbers are opinions. We'll get back to that shortly. So in the end, we had enough differentiation between the different scenarios of high, medium, and low access to cultural infrastructure. It was not our highest precision indicator, but it got the job done. And last but not the least, cost effectiveness. We need to consider our limited time and money. I'm sure you have tons of examples from your own daily work life. The one that I would like to call out from this project is at the very beginning, the data cleaning part. So as I already mentioned, grocery stores were very important. They had a very high weight in our indicators. So it was very important that we have a data set that is as accurate as possible. In our company, we have a points of interest data set. Points of interest are like shops and where they are. This stuff costs tens of thousands of dollars. It is not good. There are missing shops. There are shops in the data set that are already closed in real life. And it's really hard to have a very accurate points of interest data set. And we evaluated a lot of them. Open source ones, not very good either. Those ones that we paid a lot for, not super good. And so we had to put a lot of our own time an effort to make sure that it was as accurate as possible. Things like going on the main grocery store website and like looking by hand, where are there shops are there in our data set? And this is very time consuming. If we had infinite time and money, sure, we would have had a perfect, accurate data set, but at some point, there are diminishing returns. And when I say we, I really mean Kimberly Salt, our amazing geospatial analyst, that did this very grueling but very thorough job on our grocery stores. I said we will be back to this topic, and here we are. Numbers are opinions. So I once had a client tell me, we're hiring you because we need facts, we need numbers. Not exactly with that voice, though. And while it's true that we are measuring the real world, and the output is numbers, somewhere along the data processing chain, my opinions played a role. And by the way, I think it is desirable to embed opinions in metrics. That's kind of like the whole point. Like a metric is something that you care about. That's already like an opinion right there. But I think it's important to be clear that it's not because it is something that is measured as a number that it is absolutely purely objective. And I think it's part of my job to make sure that my clients are aware of that. So I gave myself this piece of advice that you can take as well if you want, which is to be transparent about your methodology and explicit about your opinions. I think it's important to explain your methodology in a way that the people that will use the output, your numbers, that it can agree or disagree with you. And so one tactic that we used was to actually write 2 versions of the methodology. A very detailed one for the experts and a short and to-the-point one for a wider audience. It's kind of like when you download a software and then you have like 18 pages of terms and services. Do you read them? Me neither, right? And so the idea is to give people the opportunity to grasp the methodology and participate to critique it at a level that is appropriate for them. So the experts, will scrutinize you a little bit more, and they need more information to critique you. And if they're going to critique it, be ready to discuss why you have those opinions. Which brings me to my next advice: justify your opinions with research whenever it's possible. So I have an example. This is all about examples. I have an example about the public transit indicator. In Montreal, we have 3 modes of transportation for public transit. We have buses, a subway that we call the metro, and trains that go to the outskirts of Montreal. And we weighted them differently because they have, different level of perceived quality. And those weights are opinions. These weights here mean that I believe that the metro is 10 times better than the bus, and that the train is 2 times better than the metro, thus 20 times better than the bus. And I think every Montrealer would agree with me that the metro is better than the bus. But is it 10 times better? Why not 100? Why not 1.5? How do we know? There are some things that we can measure. So for instance, the metro is 2 times faster than a bus, and it can carry 20 times more passenger. So that's where our pick of 10 comes from. It's somewhere between 2 and 20. Could have been 5, could have been 15, but when we calibrated the overall indicator, 10 worked best. It's also kind of like a nice round number. You know, we could argue all day about if this was the right choice, but I think it was. What about the perceived things? Well, there are surveys to know if people think that the train is more reliable, safe, clean, comfortable, and so on. And the train actually scored usually about 2 times higher than the metro on those things. So that's where the factor 2 comes from. And that's how we got all our weights. We showed it to our clients. They agree with that. They were happy with the end result, and all was good. Except for one thing, and this is where numbers can get weirdly political. So, in the outskirts of Montreal, there is a train station. The train doesn't run on weekends. During the weekdays, it's there mostly at peak hours. Our original methodology gave it a low score, a 2 out of 10. And when we presented that to our clients, they said, we cannot say that it is a low indicator here because the people in this region are very proud that they live near the train, and it will look very bad if we said that it was a low score for transit. So it got me thinking, well, all right, I don't live there. I'm willing to be open-minded, and that maybe there's something that we overlooked. But at the same time, I was uncomfortable. I didn't want to say the area had a good public transit if it weren't true. I didn't want to compromise on my scientific integrity just to make our client happy. I felt a bit stuck. So my colleague Colin had the amazing idea to get another vantage point by looking at another data set. So the whole point of having a good public transit system is that people use it. And it just so happens that the Canadian census reports the rate of people using transit to go to work. This is what we're looking at right now. Red is high, green is low, and the white dots are the train station. I'm not representing the bus and the metro in here. So when we looked at the area around the train stations, we discovered that this train station had an outsized effect on people's behavior, and it really did reduce car usage for going to work. The rate of commuters using public transit in that area was the same as other places in the city where the score was a 4 out of 10. This was worth something, and we recognized that our original methodology did not capture this effect very well, so we tweaked the methodology. In the end, the zone around the train station was given a medium-low score, and everyone was happy. The city could say, yes, it is medium-low with it's not completely bad, but there's room for improvement. And we were happy that this adjustment was based on facts. And as we're nearing the end of this talk, I want to highlight that something important is missing. For this project, we really focus on that part, the complete living environment. But there is something right there in the statement that we overlooked. If 70% of the population will live in these great places, who is the other 30%? Are they not living there by choice? Or is there something systemic that prevents them to live there? When designing livable city, we need to think about social justice. And by the way, the city cares about social justice. It was just not part of my mandate for this project to measure it. So I thought it was important to talk about it now so that I don't leave you with the impression that livable cities are all about infrastructures and not about the people that live in them. It matters to me that my kids can walk to go to school, and it matters to me that their kindergarten teacher can afford to live in the neighborhood and that she can also walk to go to school. Great places to live are more desirable, and so often they're more expensive too. On top of that phenomenon, Montreal is facing a housing crisis. Affordable housing is a hot political issue. And we need to tackle that problem. And how we get to do that is a very complicated puzzle. And I cannot do it alone. Fortunately, I'm not alone. I'm working on a new project. There are people with diverse backgrounds discussing how we want to make complete living environments, and adequate housing access is part of that vision. I'm mainly just helping out with the technical aspect of measuring it. It's still early days, but I have hope that this work will help cities in my province to work towards better, livable cities for everyone. And I'm also excited that geospatial data science gets to be a part of that. So to recap, we've seen the 5 criteria for good metrics. Simplicity, easy to understand. Faithfulness, captures the spirit of what we're trying to represent. Sensitivity, captures changes that matter. Precision, affords nuance. Cost effectiveness, considers our limited time and money. We've also talked about how numbers can be opinions and how I like to deal with that. I would recommend to be transparent about your methodology and explicit about your opinions, and to justify your opinions with research. And finally, I would encourage us all to consider social justice in our work. Data science can impact the lives of people, so let's make sure our cities are built for everyone, and our algorithms as well. Thank you.
Thank you so much for coming all this way from Montreal and giving this talk. I think we can relate to many things that you said about the housing crisis and stuff, and I'm really curious what you would say about the Netherlands and Amsterdam from this point of view. But first, let's see if there are any questions.
Hi, Simon here. Thank you for the great talk. I come from the geospatial background myself. And I'm wondering, you showed a great deal of spatial data right there. And what software did you use mostly to handle all this?
Yeah. What software?
Or tools?
Yes, I had to cut this slide but so that I could be on time. So thank you for asking this question. So, it's still data science, so I'm using general tools like Pandas and Jupyter. And for geospatial, to me, GeoPandas was a very useful tool. So what GeoPandas is, it's kind of like Pandas, but you get an extra special column that is called geometry, in which you can store a geometry object. Geometries are like points, lines, polygons. And GeoPandas also gives you some, the functions that you need to figure out the relationship between those geometries, like the distance between them. Do they overlap? What's the area of a polygon, and things like that. So GeoPandas was a very important part of this project. There's also other tools that I didn't use, but my colleague Colin used, that are like ArcGIS from Esri. I also use Apache Sedona. This is Spark SQL, but with geospatial capabilities, because some of my data was so big, it did not fit on my computer. Like, I did not have enough compute on my small laptop, so I had a Spark cluster, so Apache Sedona was useful there. It has its drawbacks. Maybe today I would consider something like DuckDB with the geospatial extensions to DuckDB. And for visualization, you can draw maps with a bunch of different tools, but the one that I felt was the less buggy and that worked the best for me was Folium. And yeah, I'd be happy to chat afterwards, like if you want to trade secrets of geospatial data with me.
Definitely, thank you. And use QGIS instead of ArcGIS.
Yeah, QGIS is open source, I believe. It's better and much less expensive.
Yeah, thank you for the talk. I have a question. How transferable would be this project if you were to measure any other city, let's say Amsterdam? You mentioned the issues with the data preparation, but what other challenges there would be?
I think every city has its own personality. So it's interesting that you're asking this question, because we did the same thing with the city of Quebec. And it is kind of similar to Montreal, but it's much smaller, and they don't have like the metro, and they don't have the trains. They only have buses. So there are like, just different things like that. Like they had to reweight everything. They could not just use our indicators as is. And also, what I mean by every city has its own personality, I know that some places in the Netherlands and in Japan, there are no cycling networks, but people cycle everywhere. Sometimes the best cycling infrastructure is no cycling infrastructure, just because cars, leave the space for and it's safe to be in the road with your bicycle. Not in Montreal. I prefer to be on a cycling path. So I think it really needs to be adapted in that way to the city where you are. And also like the 6 aspects that we care about in Montreal, there might be like 7 here or like 5 somewhere else. They might be different. So it needs to be really tailored to the needs of the population or the challenges of the population.
Yeah, thanks for the talk. The 50-minute city focuses a lot sort of on the local area and the local aspect, but one of the limitations is that there are services or there are needs that are basically very rare or not very dense in the city, like for example a stadium, which is typically not within 15 minutes. How do you sort of incorporate the network aspect of transit without making the metrics super complicated? So how do you balance that?
And the answer is that we don't. And that you have a great point. It's something that we thought about, that we could, say, use the transit network and use like isochrone, so meaning like instead of a 15 minutes walk radius, it could be like a 15 minutes metro radius, and count how many things that you can have there, universities, big hospitals, and that kind of stuff. But it was, like, as you said, like, how do you do that without making your indicators too complicated? Since this was our first iteration of that, we really needed to keep that simple. It's just a 15 minutes walk radius. But I think there is a world where we can go, like, we can add another layer at another time, or maybe like a different indicator that looks at that. Another very important one is access to jobs. Where will people work? Because that influences a lot, like, will they use their car or another mode of transportation? It is not part of this initial research.
Yeah, thanks a lot. I think it was a really great talk. I'm also very curious, like, what the actual product is. Is it like a one-off report? Are you giving the municipality a dashboard to keep a view on how things are evolving, and how do you deliver your product?
Yeah, that's a very good question. So the city has their own data scientists, or geospatial analysts. So our product was, the grid that I showed at the beginning, like for every like little pixel on the map, these are called geohashes. So for each of those, which are like 200,000 or so, for each of those we give each of the 6 indicators. So our product was a one-off calculation of those 6 indicators, and in 5 years we'll redo the same so that the city can see how they are progressing. But the cool thing is that what they do is that they take that data and they know where everyone lives in the city, so they can do the extra step of knowing like what percentage of the population lives in an area where the transit indicator is a 7 or more. So that's what they will do with it. But yeah, our output, our product was really the data and a very thick methodology.
Cool. Then thank you so much. That was really interesting. And join me to give a round of applause for